Welcome back to CryptoZombies. Today we're going to be starting the advanced Solidity path, getting in-depth knowledge of Solidity and coding for blockchain engineering. Our intention is to explore the intersection of voice technology and blockchain technology to see how voice technology can be built on top of Web3 blockchains. Again, we're getting started with Truffle today. If you watched the last series I did on the to-do list on blockchain, we use Truffle to develop locally and build our smart contracts and to do our testing as well. We did testing, compilation, and deployment using Truffle. So let's get started. Welcome. By completing the previous lessons, you've demonstrated that you really know your stuff. So go ahead and deploy the game to the main net. Enjoy your success. Hang on a moment. There are a few things you might have already thought of. After all, once contracts get deployed to the mainnet, they will live there forever. If there's a mistake in them, they will still live on as well, like undead zombies. Mistakes, bugs, happen to every coder, no matter how skilled. It's unlikely you would make a major mistake like giving attacking zombies a 100% chance of victory, but it could happen. Clearly, giving the attacking side 100% of the wins would mean that you've written was no longer a game. It's not even fun at all. A bug like this would just kill the game dead with no promise of juicy brains to drag your zombies from their graves. To stop this terrible thing from happening, it's essential that you thoroughly test every single aspect of your game. By the end of this lesson, you'll be able to test your smart contract with Truffle against Ganache, use Chai to write more expressive assertions, and test against Loom. Let's get started. We've got 15 chapters in this lesson, and let's see what Chapter 1 is. Chapter 1, Getting Set Up. In this lesson, we will be covering the theory behind testing Ethereum smart contracts with a focus on Truffle, Mocha, and Chai. You will need an intermediate level of knowledge of Solidity and JavaScript to help you get the most out of these lessons. If you don't have prior exposure to Solidity, or you want to revise some of the concepts, go ahead and start with our first lesson. If you're not comfortable with JavaScript, consider going through a tutorial somewhere else before starting the lesson. I recommend Free Code Camp if you need to get started with JavaScript. Free Code Camp is how I originally learned JavaScript. I got a lot of certifications from Free Code Camp, and it helped me to learn and earn my first couple jobs as a freelance engineer. Let's peep into our project. If you followed along in our previous lessons, you should have built a zombie-themed game that is largely ready, and your file structure should look like this. We've got a build folder with our contracts, and then this is the compiled code into JSON. Then we have the actual contracts before it gets built and compiled, where we have our Solidity contracts. Then a migrations and a test file, as well as a Truffle config and a truffle.json and a packagelock.json. All of this should look familiar with the to-do list that we just built in the previous video. See the test folder? This is where we're going to be putting our tests. Truffle provides support for tests written in JavaScript and Solidity, but for the scope of this lesson, we're going to keep things simple and stick to JavaScript. Put it to the test. It's best practice to create a separate test file for each contract and give it a name of the smart contract. This makes managing your tests simpler in the long run, especially as your projects grow and change. So we're just going to create the file. Super simple. Touch test / CryptoZombies.js. Boom. We did it. Go to the next lesson. Chapter 2, Getting Set Up continued. Let's move forward. In this chapter, we're going to continue setting things up so we can write and run our tests. Build artifacts. Every time you compile a smart contract, the Solidity compiler generates a JSON file referred to as build artifacts, which contain the binary representation of that contract and saves it in the build contracts folder. Next, when you run a migration, Truffle updates this file with the information related to the network. The first thing you'll need to do every time you start writing a new test suite is to load the build artifacts of the contract you want to interact with. This way, Truffle will know how to format our function calls in a way that contract will understand. Let's look at a simple example. Say there was a contract called myAwesomeContract. We could do something like the following to load the build artifacts. Const myAwesomeContract equals artifacts.require, and then the name of your Solidity contract. The function returns something called a contract abstraction. In a nutshell, a contract abstraction hides the complexity of interacting with Ethereum and provides a convenient JavaScript interface to our Solidity smart contracts. We'll be using it in the next chapter. The contract function. Behind the scenes, Truffle adds a thin wrapper around Mocha in order to make testing simpler. Since our course focuses on Ethereum development, we won't be spending much time explaining the bits and bytes of Mocha. If you're inclined to learn more about Mocha, check out their website. Once you're done with this lesson, for now you'll only have to understand what we cover here. Mocha is a simple website talking about testing. It's a testing framework for JavaScript. Group tests by calling a function named contract. It extends Mocha's describe by providing a list of accounts for testing and doing some cleanup as well. Contract takes two arguments. The first one is a string. It must indicate what we're going to test. The second parameter, a callback, is where we're going to actually write our tests. Execute them. The way we'll be doing this is by calling a function named it, which also takes two arguments, a string that describes what the test actually does, and a callback. Putting it together, here's a bare bones test. Contract, my awesome contract. We pass in an account into our callback function. We then describe a function called it, and then we describe what that test should do. It should be able to receive ethers, and then we have another callback function that is the actual test. Note, a well-thought test explains what the code actually does. Make sure the description of the test suite and the test case can be read together as a coherent statement. It's like you're writing documentation. Every test you'll want to write follows this simple pattern. Pretty easy, isn't it? Put it to the test. Now that we've created an empty CryptoZombies.js file, let's fill it in. The first line of code should declare a const named CryptoZombies and set it equal to the result of artifacts.require function with the name of the contract we want to test as an argument. Next, go ahead and copy and paste the test from above. Third, change the way we're calling contract such that the first parameter is the name of our smart contract. Don't worry about the accounts argument, we'll explain it in the next chapter. 4, the first parameter passed into the it function in our example should be able to receive ether, should be the name of our test. Since we'll start with creating a new zombie, make sure the first parameter is set to should be able to create a new zombie. We're all set, let's move on to the next chapter. Okay, so the first line, we want to create a const called CryptoZombie, and we want to set it equal to artifacts.require, and then with the name of the contract we want, and I don't know what the name of the contract is that we want. I guess CryptoZombies. Next, go ahead and copy and paste the test from above. We'll just copy and paste the test. Change the way we're calling contract such that the first parameter is the name of our smart contract. It's a string. We'll make it CryptoZombie. Whoops. The first parameter we want to set to should be able to create a new zombie. Paste that. Let's check the answer. I'm not sure what we want to be doing here. The first line of the code declares a const named CryptoZombies, set it equal to the result of artifacts.require function with the name of the contract we want to test as an argument. I might need to change that. Let's try again. We're still not doing it right. Let's see the answer. This should have been plural. And then this should be plural of CryptoZombies. Is that the only thing I did? We just needed it to be plural. That's an easy one. Seems it's having trouble going from chapter to chapter. Chapter 3, the first test, creating a new zombie. Before deploying to Ethereum, it's best to test your smart contracts locally. You can do so by using a tool called Ganache, which we have also used in our previous versions. I've got Ganache locally installed, and it's a local blockchain. So if we check out Ganache, it gives us, in our quick start, 10 different Ethereum accounts, each with 100 Ethereum. That gives us a lot of wiggle room to be able to play around with our local blockchain applications. If you want to learn more, just head over to the Truffle Suite Ganache website. Every time Ganache starts, it creates 10 test accounts and gives them 100 ethers to make testing easier. Since Ganache and Truffle are tightly integrated, we can access these accounts through the accounts array we've mentioned in the previous chapter. But using accounts 0 and accounts 1 would not make our tests read well, right? To aid comprehension, we'd like to use two placeholder names, Alice and Bob. So inside the contract function, let's initialize them. So let Alice and Bob equal accounts. I'll wait till we get to the to-do section. Forgive the poor grammar. In JavaScript, the convention is to use lowercase for variable names. Why Alice and Bob? There's a big tradition that makes Alice and Bob, or A and B, common names used in cryptography, physics, programming, and more. It's a short but interesting history, and well worth a read after you complete the course. Oh, that's cute. That's really cute. Okay, I'll keep that open till the end. Let's move on to our first test, creating a new zombie. Say Alice wants to play our awesome game. If so, the first thing she would want to do is create her own zombie. To do that, the front end, or Truffle in our case, would have to call the createRandomZombie function. As a review, here's the Solidity code in our contract. CreateRandomZombie, pass in a name. We did this in the previous section. We then have a require statement to make sure that they haven't created their first zombie before. We generate some random DNA. We set we use modulo 100 to make sure that we get the right random DNA, and then we create our zombie. Put it to the test. First line of our contract function should declare two variables named Alice and Bob and initialize them as shown above. Next, we want to properly call the it function. The second parameter, which is a callback function, is going to talk to the blockchain, which means that the function is asynchronous. Just prepend the async keyword. This way, every time this function gets called with the await keyword, our test waits for it to return. Explaining how promises work is outside of the scope of the lesson. Once you've finished, feel free to check out the official documentation to further your knowledge. Promises directly on the Mozilla website. Okay. So, first thing we want to do is initialize the Alice and Bob. So we are going to set let Alice and Bob. I'm about to get some heavy rain behind me, so sorry for any noise. It's rainy season here in Thailand. Alice and Bob equals accounts. Next, we want to properly call the it function. The second parameter, a callback function, is going to talk to the blockchain. I've got a fan that's sitting out under the plug, so I'll be right back. Give me just 1 second. Gonna take one breath to acknowledge the change with the rain. Next, we want to properly call the it function. The second parameter is going to talk to the blockchain, which means that the function is asynchronous. So we want to add the async keyword, and that's it, I think. That was it. Simple. Moving on to chapter 4. Chapter 4, the first test, creating a new zombie. Great job. Now that we have a shell for our first test, let me walk you through how testing works. Usually, every test has the following phrases. Setup, in which we define the initial state and initialize the inputs. Act, where we actually test the code. Always make sure you test only one thing. Third, assert, where we check the results. Let's look at what our test should do in some more detail. 1. Setup. In Chapter 2, you created a contract abstraction. However, a contract abstraction, as the name says, is just an abstraction. In order to actually interact with our smart contract, we have to create a JavaScript object that will act as an instance of the contract. Continuing our example with my awesome contract, we can use the contract abstraction to initialize our instance like this. Const contract instance equals await myawesomecontract.new. So what's next? Calling create random zombie requires us to pass it the zombie's name as a parameter. So the next step would be to give a name to Alice's zombie, something like Alice's awesome zombie. However, if we do this for each test, our code is not going to look pretty. A better approach is to initialize a global array as follows. Const zombie names equals zombie1 and zombie number 2. And then call the contract's methods like so. Contract instance.create random zombie, and then in parentheses zombie name 0. Note, using an array to store zombie names come in handy if you want, for example, to write a test that creates 1,000 zombies instead of just 1 or 2. Put it to the test. We've gone ahead and initialized the zombie names for you. Create an instance of our contract, declare a const named contract instance, and set it equal to the result of CryptoZombies.new function. CryptoZombies.new talks to the blockchain. This means it's an asynchronous function. Let's add the await keyword before the function call. Alright, so inside of our first test, we want to declare a const called contract instance. I'm going to copy and paste it to make sure I get it right. And then we'll use our CryptoZombies.new function. Because we're interacting with the blockchain here, we want to use await. That should be everything. We got it. Next lesson, chapter 5. Oh, chapter 4. I just did chapter 4. Chapter 5. Okay, it's not liking me moving on to chapter 5, so I'm going to do this lesson again real quick. Now we can go. Chapter 5, the first test, creating a new zombie, continued. Now that we've got our ducks in a row, let's move on to the next phase. Act 2. We've reached the part where we're actually going to be calling the function that creates a new zombie, create random zombie. But there's a slight problem. How can we make it so the method knows who calls it? Another way to put it would be, how can we make sure Alice and not Bob is going to be the owner of this new zombie? Well, the problem is solved with the contract abstraction. One of the features of Truffle is that it wraps the original Solidity implementation and lets us specify the address that makes the function call by passing that address as an argument. The following calls create random zombie and make sure message.sender is set equal to Alice's address. This looks exactly like what we did in our to-do list app. Now I have a quick question for you. Do you know what gets stored in result? Well, let me explain. Logs and events. This is a good question because I wasn't sure what got stored in results, and now we're actually going to go through and explain it. Once we specified the contract we want to test using artifacts.require, Truffle automatically provides the logs generated by our smart contract. What this means is that we can now retrieve the name of Alice's newly created zombie using something like result.logs.args.name. In a similar fashion, we can get the ID and the DNA. Besides these little bits of information, Result is going to be giving us several other useful details about the transaction. We can get the transaction hash, the object containing the transaction receipt, and then the status of the receipt to tell whether or not the transaction was successful. Note, their logs can also be used as a much cheaper option to store data. The downside is that they can't be accessed from within the smart contract itself. Third, assert. In this chapter, we're going to be using the built-in assertion module, which comes with a set of assertion functions such as equal and deep equal. Simply put, these functions check the condition and throw an error if the result is not as expected. Since we'll be comparing simple values, we're going to just be running assert.equal. Let's put it to the test, finish off our first test. 1. Declare a const name result and set it equal to the result of the contract instance.createRandomZombie with the zombie's name and the owner as arguments. Second, once we have the result, call assert.equal with 2 arguments, result.receipt.status and true. If the above condition is true, we can assume that our test has been passed. Just to be safe, we'll add one more check while we're here. In the next line, check if results.log0 arg's name equals zombie's name 0. Use assert equal just like we did above. Now, it's time to run Truffle Test to see if the first test passed. The way this works is that Truffle will just inspect the test directory and execute the file it finds there. Actually, we've gone ahead and done that for you. The output should look something like this. If you look at our previous videos, we have already run contracts similar to this on our local machines in the to-do list lessons. This concludes your very first test. Well done. There are several more to come, so let's get going on the next lesson. Let's get started. Number 1. We're going to create a const called result. We're going to set it equal to contract instance dot create random zombie, and then we're going to pass in the zombie's name. I think we want zombie names 0, and then we're also going to want to pass in the owner. I think it's going to be from accounts. We might just be able to put Alice here. Zombie names 0, and then from Alice. This looks the same. 1 is done, unless it needs to be async, which it does. So we need to await. Number 2, once we have the result, call assert.equal. So we'll go assert.equal, and then we'll pass in result.receipt.status, and we want to assert that the status is true. After that, we want our second assert, which is going to be assert.equal. And inside of here, we want to make sure that results.logs0.args.name is equal to zombie names 0. We want to assert that the name of our zombie is Alice. Don't open Discord, no. Got it. Chapter 6. Chapter 6. Keeping the fun in the game. Awesome work so far. Now that we know for sure our users can create new zombies. However, if they could keep calling this function to create unlimited zombies in their army, the game wouldn't be any fun. Thus, in Chapter 4 of Lesson 2, we've added a require statement to the create zombie function that makes sure each user can't own more than one zombie. Boom. Let's test this feature and see if it works. Hooks. In just a few minutes, we'll have more than one test, and the way this works is that each test should start with a clean sheet. Thus, for every single test, we have to create a new instance of our smart contract like so. Create the new contract. Wouldn't it be nice if you could write this just once and have Truffle run it automatically for every test? Well, one of Mocha's and Truffle's features is the ability to have some sequence of code called hooks run before or after a test, to run something before a test gets executed. The test should be put inside of a function called before each. So instead of writing contract.new several times, You just do it once like this. Before each with a callback function that we can make asynchronous. So let's put here the code that creates a new contract instance. Then Truffle will take care of everything. It's pretty sweet, isn't it? Put it to the test. 1. Before the line of code that initializes Alice and Bob, let's declare a variable called contract instance. Don't assign it to anything. Note, we want contract instance to be limited in scope to the block in which it's defined, so use let instead of var. Next, copy and paste the snippet from above for defining the before each function. Third, let's fill in the body of our new function. Go ahead and move the line of code that creates a new contract instance inside of before each function. Now that we've defined contract instance somewhere else, you can remove the const qualifier. 4. We're going to want a new empty it function for our test. Set the name of the test, that is the first parameter we're passing into the it function, equal to should not allow two zombies. We'll continue fleshing out this function in the next chapter. We'll read this after we do the put it to the test. Below the line of code that initializes Alice and Bob, let's define a variable called contract instance. So we'll go const I think we want it to be a const. Oh, we'll make it a var. Oh, nope, we want it to be let. Second, copy and paste the snippet above for the before each function. Fix our tabs. Third, fill in the body of our new function. Go ahead and move the line of code that creates a new contract instance inside of the before each function. Now that we've defined contract instance somewhere else, we can remove the const qualifier. Since we've defined it up here, we don't need the const qualifier. Next, we're going to want a new empty it function for our test. We'll copy the it. Actually, we won't copy it. We'll actually use it. We'll do it. It should not allow two zombies. And then after the string, we then want an asynchronous callback arrow function. And we're going to leave it empty. Let's check our answer. We got it. I don't think it'll skip us ahead, so once we get that, how do I get rid of this? Let's just refresh here so that I can see the words. Here be zombies of every kind. If you really want to achieve mastery, go ahead and read on. Otherwise, just click next and off you go to the next chapter. Still around? Awesome. After all, why would you want to deny yourself a whole lot of awesomeness? Now let's circle back to contract.new and how it works. Basically, every time we call this function, Truffle makes it so that a new contract gets deployed. On one side, this is helpful because it lets us start each test with a clean sheet. On the other side, if everybody would create countless contracts, the blockchain would become bloated. We want you to hang around, but not your old test contracts. We want to prevent this from happening, right? Happily, the solution is pretty straightforward. Our contract should self-destruct once it's no longer needed. The way it works is as follows. First, we would want to add a new function to the CryptoZombies smart contract like so. Function kill public only owner self-destruct owner. Note if you want to learn more about the self-destruct, you can read Solidity docs here. The most important thing to bear in mind is that self-destruct is the only way for code at a certain address to be removed from the blockchain. This makes it a pretty important feature. Next, somewhat similar to the before each function explained above, we'll make a function called after each. After each, contract instance dot kill. That will self-destruct. It'll self-destruct. Lastly, Truffle will make sure this function is called after a test gets executed. And voila! The smart contract removed itself. We have a lot of ground to cover in this lesson, and implementing this feature will likely require at least 2 additional chapters, so we trust you to add it. Let's move on to chapter 7. Chapter 7, keeping the fun in the game continued. In this chapter, we're going to fill in the body of our second test. Here's what it should do. First, Alice should call create random zombie and give it zombie name 0 as the name of the first zombie. Next, Alice should try to create her second zombie. The only thing that's different this time is that the zombie's name should be set to zombie names 1. At this point, we expect the contract to throw an error. The contract, not the test. Since our test should pass only if the smart contract errors out, our logic looks a bit different. We'll have to wrap the second create zombie function inside of a try-catch block as follows. Try, assert true, catch, return. Now we've got exactly what we wanted, right? We're pretty close, but not quite there. I think we want this assert function inside of the catch. In order to keep our test nice and tidy, we moved the code above to helpers utils and imported the CryptoZombies.js like so. Utils is helper utils, and this is how the line of code that calls the function should look like. Oh, nice. Okay, so there's a built-in function for throwing errors. Put it to the test. In the previous chapter, we created an empty shell for our second test. Let's now fill it in. First, let's have Alice create her first zombie. Give it zombie name 0 as the name, and don't forget to properly set the owner. Second, after Alice creates her first zombie, run should throw with create random zombie as the parameter. If you can't remember the syntax, check the example from above, but first, try it without peeking. Awesome. You've just finished writing your second test. Now we've gone ahead and run Truffle Test. Here's the output that we should get. We get checks to passing tests. Let's put it to the test. 1. First, let's have Alice create her first zombie. Okay, let's get started. Don't forget to properly set the owner. I think this is exactly the same as above, right? Okay. Run should throw. So now we want to go await utils dot should throw CryptoZombies. Oh no, we want to use contract instance. Contract instance dot create random zombie and then I think we want to do the same thing. What did we do wrong? First, let's have Alice create her first zombie. Give it zombie name 0 as the name, and don't forget to properly set the owner. I guess we don't need to store the result. Maybe that's it. That was it. Don't store the result. We passed our tests, and we've also passed halfway through this lesson. We're now on chapter 8 out of 15. Chapter 8, Zombie Transfers. Question. Say Alice wants to send her zombie to Bob. Shall we test this? For sure. If you've been following along from the previous lessons, you should know that amongst other things, our zombies inherit the ERC721, and the ERC721 specification has 2 different ways to transfer tokens. We've got the transfer from function, and the first way Alice has is by calling transfer from with her address as the from and Bob's address as the to, and the zombie ID she wants to transfer, and that's just going to be a direct transfer to Bob's address from Alice's. The second is approve followed by transfer from. The second way, Alice calls the approve function with Bob's address that then stores Bob is approved to take the zombie. Next, when Alice or Bob calls the transfer from, the contract checks that message.sender is equal to Alice or Bob's address. If so, it transfers the zombie to Bob. We'll call these two ways of transferring zombies scenarios. In order to test each scenario, you want to create two different groups of tests and give them meaningful descriptions. Why group them? We only have a few tests. Yes, right now our logic is pretty straightforward, but this might not always be the case. Still, the second scenario, that is approve followed by transfer from, requires at least two tests. First, we must check if Alice herself is able to transfer the zombie. Second, we also have to check if Bob is allowed to run transfer from. Moreover, in the future, you might want to add other functionalities that would require different tests. We believe it's best to put a scalable structure in place from the very beginning. It makes understanding your code much easier for outsiders, or for yourself if you spent time concentrating on something else for a little while. Note, if you end up in a position where you're working with other coders, you'll find they're more likely to follow whichever conventions you've laid down in your initial code. Being able to collaborate effectively is one of the key skills you'll need if you ever want to work on big, successful projects. Getting good habits that help you do this as early as possible will make your life as a coder easier and more successful. The context function. To group tests, Truffle provides a function called context. Let me quickly show you how to use it in order to better structure your code. We've got context with a single tap transfer scenario, and then we've got another context with the two-step transfer scenario. Each context has multiple tests inside of it. If we add this to our CryptoZombies file and then run Truffle Test, the output would look similar to. It then prints out our context for easier testing output and testing logs. Well, take a look again. There's an issue with the above output. It looks like all tests have passed, which is obviously false since we didn't even write them yet. Fortunately, there's an easier solution. If we just place an X in front of the context function as follows, Truffle will skip those tests. Note, X can be placed in front of an it function as well. Don't forget to remove all the X's when the tests of those functions have been written. Now let's run Truffle Test. The output should look something like this. Where dash represents a test that's been skipped with the X marker. Pretty neat, huh? Now you can run your tests as you go along and mark out empty functions where you know you'll need to write tests in the near future. Put it to the test. Go ahead and copy and paste the code from above. For now, let's skip our new context functions. Our tests are just empty shells, and there's a lot of logic to be written in order to implement them. We'll do it in smaller pieces over the coming chapters. We're just going to copy the code from above. I'm not even going to worry about tabs. Let's skip our new context functions. What do we do? Is it the tabs? No way is it the tabs. It's not the tabs. If you have any... Okay, it looks like it doesn't like our context. So let's just use the tests first, I think. What don't you like? What did we do wrong here? Is it tabs? Tabs are never the answer, but I just want to check. It's not. Copy and paste the code from above. Let's undo all this. And let's copy and paste the code from above. I'm not sure what's going on, so let's show the answer. Oh, it needs the X context? Well, that's silly. Oh, that's what I meant by I didn't understand what it meant by let's skip them. We need to put the X's in front so that it actually skips it. I should have guessed. Let's move on to Chapter 9. Chapter 9, ERC 721 Token Transfers Single Step Scenario. So far we've merely been warming up, but now it's time to really show off what you know. In the next chapters we're going to be putting what you've learned together and test something really cool. To begin with, we're going to be testing the scenario in which Alice transfers her ERC 721 token to Bob. If you don't know what ERC 721, you can replace NFT and the same meaning can be applied. Here's what our test should do. Create a new zombie for Alice. Remember that the zombie is nothing more than an ERC 721. Make it so that Alice transfers her ERC 721 token to Bob. At this point, Bob should own the ERC 721 token. If so, owner of would return a value that is equal to Bob's address. Let's wrap it up by checking if Bob is the new owner inside of an assert. Put it to the test. The first line of the function should call create random zombie, give it zombie name 0, and make sure Alice is the owner. Second should declare a const name zombie ID and set it equal to the zombie's ID. In Chapter 4, you learned how to retrieve this piece of information, refreshing your memory if needed. Then, we have to call transfer from with Alice and Bob as the first parameters. Make sure Alice calls this function, and we're waiting for it to finish before moving to the next step. 4, declare a const called new owner. Set it equal to owner of called with zombie ID. 5, lastly, let's check whether Bob owns this ERC 721 token. Putting this into code, it means we should run assert equal with new owner and Bob as parameters. Note, assert.equal new owner Bob and assert equal Bob new owner are basically the same thing, but our command line interpreter is not too advanced, so it won't consider your answer correct unless you type the first option. Did I say the previous is the last one? Well, it's a lie. The last thing we want to do is unskip the first scenario by removing the X. It's a lot of code. Hopefully you managed to get it right. If not, feel free to click show answer. Now let's run Truffle Test to see if our new test pass. And there it is, our code is passed the test with flying colors. In the next chapter, we're going to move on to step 2, scenario in which approve is followed by transfer from. Let's put it to the test. The first line of our function should call create random zombie. We're just going to copy where we're already doing that. Creating random zombie, we're making sure Alice is the owner. Second line should declare a const called zombie ID and set it equal to the zombie's ID. Oh, putting this in the wrong part. Result dot logs 0 dot args dot id I think that's it. Then we'll call the transfer from with Alice and Bob as the first parameters. Make sure Alice calls this function and we're waiting for it to finish before moving to the next step. So now we're going to say await transfer contract instance dot transfer from. So now we're going to pop in Alice and Bob, and then we want Alice to be calling this, so we're going to say from Alice. Next, declare a const called new owner. Set it equal to owner of called with zombie ID. Lastly, let's check whether Bob owns the ERC 721 token. Putting this into code, it means we should run assert.equal with new owner and Bob as parameters. Assert assert.equal what is owner of? I'm not sure what owner of function is, or where that's coming from. Now we want to unskip this context. Yeah, I had a feeling something was going to be wrong. So now we need to get the ID of our zombie, and it looks like I'm doing that incorrectly. I'm just going to show the answer because I'm not sure what we should be doing here. So we want zombie ID dot to number. I'm not sure how we would have known the to number function should be used. Next up, I never did the zombie ID. And then finally, this should be, okay, I had it right the first time. This should be await contract instance dot owner of, and now we got it. Okay. Chapter 10, ERC 721 token transfers, two-step scenario. Now the approve followed by transfer from way to transfer ERC 721 tokens is far from being a walk in the park, but I'm here to help. In a nutshell, we have to test two different scenarios. One in which Alice approves Bob to take the ERC 721, then Bob the approved address calls transfer from. Alice approves Bob to take the ERC 721 token. Next, Alex transfers the ERC 721 token. The difference in the two scenarios lies with who calls the actual transfer, Alice or Bob. We've made it look simple, right? But let's take a look at the first scenario. Bob calls transfer from. The steps for this scenario is as follows. 1. Alice creates a new ERC 721 token and then calls approve. Next, Bob runs transfer from, which should make him the owner of the ERC 721 token. Finally, we call assert.equal with new owner and Bob as the parameters. Put it to the test. First two lines of code in our test are similar to the previous test. We've gone ahead and copied and pasted them. Second, in order to have Bob approve to take the ERC 721 token, call approve. The function takes Bob and zombie ID as parameters. Also make sure that Alice calls the method since it's her token. Last three lines of the code are almost similar to the previous test. Again, we've gone ahead and copied and pasted them. Let's update the transfer from function so that the sender is Bob instead of Alice. Lastly, let's unskip this scenario and skip to the last test case, the one we still have to code. Time to run. We see that it passes. Let's put it to the test. One is already done. It's already been copied and pasted. Boom, we see that right here. 2. In order to have Bob approved, call approve. So we will await contract instance dot approve. We want to pass Bob in first, and then the zombie ID that he's approved for, followed by the sender, which is going to be from Alice. Last three lines of code are very similar. Copied and pasted. Update transfer from, so that instead of Alice calling it, it's Bob, because Bob has now been approved. Lastly, let's unskip the scenario. Are we really getting this one wrong too? Test. And skip the last test case. I didn't do that. Skip the last test case. Now let's try again. That was it. I'm glad I didn't check the answer. It's nice to sometimes feel a little bit of uncomfortability and not just take the easy way out. 11:11, lesson 11, chapter 11, 11. Chapter 11, ERC 721 token transfer. Two-step scenario. We're close to being done with testing the transfers. Let's now test the scenario in which Alice calls transfer from. We have some good news. The test is very straightforward. All you have to do is copy and paste the code from the previous chapter and make it so Alice is the one that calls transfer from. Put it to the test. Copy and paste the code from the previous test and have Alice call transfer from. Unskip it and we're all set to go. Then we run Truffle Test. Can't think of any other test that's related to transfer, so we're done for now. Let's get started. Put it to the test. 1. Copy and paste the code. Copy and paste everything. Boop. And then we change and have Alice call the transfer from. And then we want to uncomment it so it gets run. And we got it. First try. Gotta love it. Moving on to chapter 12. Chapter 12. Zombie attacks. Wow, the previous chapters were pretty information dense, but we covered a lot of ground. I can agree. My eyes even started to glaze over, and I'm reading it. So we're done now with all the scenarios. Nope, not there yet. We've left the best stuff for the end. We built a zombie game, and the best part is where the zombies fight each other, right? This test is pretty straightforward and consists of the following steps. First, we're going to be creating 2 new zombies, one for Alice and the other one for Bob. Second, Alice will run attack on her zombie with Bob's zombie ID as a parameter. Finally, for the test to pass, we're going to check if result.receipt.status equals true. While we're here, let's say I've quickly coded all the logic, wrapped it in an it function, and run Truffle Test. Then the output would look something like this. We get 1 failing. Uh-oh, our test just failed, but why? Let's figure it out. First, we're going to take a closer look at the code. So far, so good. Let's dig into the create zombie. Oh, you see the issue? Our test failed because we've added a cooldown period to our game and made it so our zombies have to wait 1 day after attacking to try again. Without this, the zombie could attack and multiply countless times per day, which would make our game way too easy. Now, what should we do now? Wait for a day? Time traveling. Fortunately, we don't have to wait that much. In fact, there's no need to wait at all because Ganache provides a way to move forward in time through 2 helper functions. EVM, increase time, increases the time for the next block. EVM mime, mimes a new block. Mines a new block. You don't even need a TARDIS or a DeLorean for this kind of time travel. Let's explain how the functions work. Every time a new block gets mined, the miner adds a timestamp to it. Let's say the transaction that created our zombies got mined in block 5. Next, we call EVM underscore increase time, but since the blockchain is immutable, there's no way of modifying an existing block, so when the contract checks the time, it will not be increased. If we run EVM underscore mine, block number 6 gets mined and timestamp, which means that when we put the zombies to fight, the smart contract will see that a day has passed. Putting it together, we can fix our test by traveling through time as follows. Web3, current provider, send async with an EVM, increase time. We set it to increase the time by a day, and then we get the time. And then we send the mine with the time. Yeah, it's a nice piece of code, but we wouldn't want to add this logic to our CryptoZombies file. We've gone ahead and moved everything to a new file named helpers.time.js. To increase the time, you'll simply have to call time.increaseTime. Yeah, still not good enough. After all, do we really expect you to know how many seconds there are in a day right on top of your head? Of course not. That's why we've added another helper function named days that takes the number of days we want to increase time with as an argument. So you can call this function await time increase time.duration.days1. Obviously, time traveling is not available on the mainnet or any of the available test chains that are secured by miners. It would make a real mess of things if anyone could just choose to change how time operates in the real world. For testing smart contracts, time travel can be an essential part of the coder's repertoire. Put it to the test. We've gone ahead and filled out the version of the test that fails. Scroll down to the comment we've left for you. Next, fix the test case by running await time increase as shown above. Now we're all set. We run Truffle Test and we get all our passing tests. This one only has one test. Let's put it to the test. We'll scroll down to our comment, increase the time. We'll do that with await time dot increase, and then inside of here we want to set it equal to time dot duration dot days, and pass inside of there parameter of 1. Check our answer. We get good to go. We are moving on to chapter 13. Chapter 13, more expressive assertions with Chai. Until now, we've been using the built-in assert module to write our assertions. While not bad, the assert module has a major drawback. The code doesn't read well. Fortunately, there are several better assertion modules out there, and Chai is one of the best. Mocha and Chai is what we use in Jovo, so if you've ever worked with Jovo, you're already familiar with both Mocha and Chai. If you want to learn more about testing with Mocha and Chai for Jovo or other voice applications, you can check out our course Ultimate Voice Developer Bootcamp. And if you want to get it for free, just send me a DM on Twitter at Voice First AI, and I will give you a coupon code to take the course for free. Chai Assertion Library. Chai is very powerful, and for the scope of this lesson, we're just going to scratch the surface. Once you finish this lesson, feel free to check out their guides to further your knowledge. That said, let's take a look at 3 kinds of assertion styles bundled into Chai. Expect lets you chain natural language assertions as follows. Lesson title, and then we expect lesson title to be a string. Should allows for similar assertion as expect, but the chain starts with a should property. Lesson title should be a string. Assert provides the notation similar to the packaged with Node.js, several additional tests, and it's browser compatible. Assert type of, lesson title, string. In this chapter, we're going to show you how to improve your assertions with expect. We're assuming the Chai package is already installed on your computer. If that's not the case, you can easily install it with the global install command. In order to use the expect style, the first thing we should do is import it into our project as follows. Expect require Chai expect expect.to.equal. Now that we've imported the expect into our project, check if 2 strings are equal would look something like below. Zombie name is equal to myAwesomeZombie, and expect zombie name to equal myAwesomeZombie. Enough talking, let's finally put Chai's powers to some good use. Put it to the test. Import expect into our project. 2. Continuing the above example with zombie name, we can use expect to test for a successful transaction as follows. Expect the status of the receipt to equal true. And we can check if Alice owns the zombie like this. Expect zombie to owner to equal Alice. Replace all occurrences of assert.equal to expect. We've left a bunch of comments in the code to make them easy to find. Put it to the test. 1. Import expect into our project. We'll copy this Chai and we'll put it up top. Continuing the above example with zombie name, we can use expect to test for a successful transaction as follows. Expect result.receipt.status .to.equal true. We'll do the same thing on our second one. Expect results logs args names .to.equal zombie name. We'll do the same thing down here for this assert. We're going to make it expect new owner .to.equal Bob. And then I think we got a couple more. Expect new owner dot to dot equal Bob. Again, I think this is the exact same. And then we'll change this last one. Expect dot to dot equal true. Did we do it right? We did. We are moving on to chapter 14 of lesson 11. Testing against Loom, chapter 14. Impressive, you must have been practicing. Now this tutorial would not be complete without showing you how to test against Loom testnet. Recall from our previous lessons that on Loom, users have access to much speedier and gas-free transactions than on Ethereum. This makes dApp chains a much better fit for something like a game or a user-facing dApp. And you know what? Deploying and testing against Loom is not different at all. We've gone ahead and summed up what needs to be done so you can test against Loom. Let's have a quick look. Configure Truffle for testing on Loom. First things first, let's tell Truffle how to deploy on Loom testnet by placing the following snippet inside the networks object. This is going to be inside of our Truffle config, I believe. Never reveal your private key. We're only doing this for the sake of simplicity. A much safer solution would be to save your private key into a file and read its value from that file. If you do this, make sure you are pushing that file in which you saved your private key to GitHub where anyone can see it. Make sure you avoid pushing the file. The accounts array. In order to make Truffle talk to Loom, we've replaced the default hardware wallet provider with our own Truffle provider. Wonder what this looks like. Is this Loom? Loom Truffle provider. Interesting. As a result, we have to tell our provider to fill in accounts array so we can test our game. In order to do that, we're required to replace the line of code that returns a new Loom Truffle provider. Return new Loom Truffle provider, chain ID, write URL, read URL, private key. With this. Loom Truffle provider, okay, bunch of code, put it to the test. All of this is specific to Loom, so if you don't plan on building on Loom, not super essential, but Loom is awesome because they gave us CryptoZombies, so we're going to keep respecting and playing inside of Loom's environment. Replace the line of code that returns a new Loom Truffle provider with the snippet from above. There's one more thing we should take care of. Time traveling is only available when you're testing against Ganache, so we should skip this test. You already know how to skip a test by placing an X in front of the function name. However, this time you want to learn something new. Long story short, you can skip a test by simply chaining a skip function call as follows, it.skip. We've gone ahead and skipped the test for you, then we ran Truffle Test. You entered the commands from above. The output should look something like this. That's all for now, folks. We've finished testing our CryptoZombies smart contract. Let's put it to the test. Replace the line of code that returns a new Loom Truffle provider with the snippet from above. Replace the line of code that returns a new Loom Truffle provider, okay, with the snippet from above. Cool. We've created the extra accounts with mnemonic intent. Are we good or do I need to skip it? We're good. I think we finished. I think we're done testing. We made it to chapter 15. Closed out another lesson. We finished testing the game. You're nothing short of extraordinary. Even though in this case our game was built for demo purposes, it's clear that testing a Solidity contract is no mean feat. But we know that now you're well equipped to test your smart contracts. The important things to remember are, make sure you keep a separate test for each function in your game. Keep everything clearly labeled and organized. Make use of time traveling. Consider using Loom when developing a game or a user-facing dApp. We highly recommend you get started by checking out our documentation. All done. We just completed level 1 of the Advanced Solidity path. That's it for today. If you have any questions, please let me know. Otherwise, this is Sweets signing off.